Good afternoon and welcome back to the extravaganza that life is. So what I'm going to look at today, this is the year 11 stuff, it's radioactivity or nuclear physics, whatever you like to call it. I'm going to test yourself questions 12 to 16 away. I'll not be doing 15 or 16, you will. 12 to 16, page 416. And what I really want to do here is show you how to draw the tables for half-life. Then you draw the tables, you draw the graph to a high standard, you then take a planned photograph of your work that you should have some pride in, you upload it to me and I'll mark it. It'll be time bound and I'll record it. So if I ever have to use it, I've got evidence. So it's up to you, I'm doing my bit. What I want you to do is to do your bit and do these tables and submit them back to me. What have I got on the table at the minute? I've got a ruler, pencil and a calculator and the magic pen and paper. And after that, I don't need anything else. So I'm going to talk through these questions and then I want you to do on the A4 page to upload them and I'll mark them. So let's start with number 12. Calculate the half-lives of the following samples. So it says a sample of iodine 123 whose activity falls from 1000 becquerel to 250 becquerel in 14.4 hours. So I'm going to draw a table. So question 12. So we've got the activity on one of the tables and it's measured in becquerel. We've got the half-life T subscript a half and we'll have time. And again it's a table, so taking the ruler, listen, oh, I can't even hear it. There's the ruler falling onto the page anyway. And I draw a line under it. See, the trouble is sometimes on there, a bit slow, a bit like myself, a bit slow. And there's the table drawn. So it tells me the activity falls from 1000, so in one half-life it'll fall to 500. So if you, in two half-lives it falls to 250. So if you look at it even as radioactive nuclei, there was 1000 starting off with. After one half-life there's 500. 500 have changed, they don't disappear. And then it changes to 250. So 750 have changed. Fair enough? So that's the activity measured in becquerel after dear old Henri. You probably thought I was French there, didn't you? So there's no half-lives, one half-life, two half-lives. The time, it tells me it's 14.4 hours. So the time is measured in hours. Do you see why I put that into the table? Half-life has no unit. And these are one of these things you get into habit, you grand. So two half-lives is 14.4 years. So one half-life is 7.2 years. Fair enough. And there's the table drawn. Right, let's do question B. So it's 12B. A sample of tactinium-99 whose activity falls from 200 becquerel to 25 becquerel in 18 hours. So I'm going to draw the table. Using my ruler yet again. There's my table. Right, so we'll write down the word activity. That's E-T-I-V-I-T-Y. And it's measured in becquerels. And there's my half-life T subscript a half. And the time, this time is measured in hours. So the time in hours. And it tells me it goes from 200 to 25. So 200 to start off with. 100, 50, 25. See, every time I'm having it, that's no half-life. 1, 2, 3 half-lives. And it tells me the time is 18 years is 3 half-lives. So 18 divided by 3 gives me 6. So that's 6, 12. Yes. So what's the half-life of this? 6 hours. Let's do question C. C for cat. So I'm going to draw the table. Again, it's very important to draw the tables because the tables tell you a lot. So there we are. The activity is measured in becquerels. At least the pen's working better this time than the last time. There's my half-lives and this is the time. Now remember, half-life times can be from fractions of seconds to millions of years. That's why I'm checking it. It's measured in years this time. See why it's in the table? So it goes from 500 becquerel. So we start off with 500. then it's 250, 125, 62.5. I'm halving it each time. No half-life, 1 half-life, 2 half-lives, 3 half-lives. And 3 half-lives is 68.4 years. That's 3 half-lives. Look, there's it there. So, calculator, you'll hear it. You have to do everything divided by 3. Oh, better turn the machine on. 86.4 divided by 3 is 28.8. So 1 half-life is 28.8. So multiply it by 2 and I get 57.6 years. And you see where I have it all filled in now. So the half-life is 28.8 years. Let's do question 13. It says, calculate how long it would take for the following to decay to an activity of 1 becquerel. Right, so activity, I better label it question 13. Activity, measured in becquerel, number of half-lives, time. So let's write down, let's draw the table. See why I'm using a ruler. You see, what's the first activity? The first one's years. So I'll put it on the table. Start off at 64, 32, 16, 8, 4, 2, 1. Now, that's no half-lives, 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, 6 half-lives. Ah, you're right, are you? Is it going to put the 6 in for me? Hang on. No. So, run to the page. But not according to the page, I haven't run to the page. So, 6 half-lives, I'll pretend that it's in there, is 31.62 years. That's 6 half-lives. So it's, I'm getting the calculator right, 31.62 to decimal places divided by 6 gives me 5.27. So 1 half-life is 5.27 years. Fair enough? So you take the 6 half-lives is 30, so the answer is 31.6 years. I made a bit of a hames of that, but because we're running out of space down here, you know 1 half-life and you know it's 6. So I'll do the next one a bit better, but just do it and you'll see. Tells you. Right. Iodine 131, half-life of 8 days, 128. So let's write down the activity. God. Not enough writing at once. The activity measured in becquerels, the number of half-lives and the time. Right, so I've drawn the table, and this time in this case is days. And the reason I do that is every time I do that, I'm training my brain. Whenever I do tables that I know, I'll check that. Don't say I'll do it in the exam because you won't. It starts off at 128. So 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So no half-lives, 1 half-life, 2 half-lives, 3 half-lives, 4 half-lives, 5 half-lives, 6 half-lives, 7 half-lives, right? 7 half-lives. So it's 7 by 1 half-life, which happened to be 8 days. So 7 by 8 is 56 days it takes for that to decay. Fair enough? And let's do C. And it says polonium-210, half-life 138 days. So there's the number of half-lives. You see my time. See, it tells me 138 days. So it's days. So it started off at what? 32. I'll better draw the table. No point pontificating about tables and then not drawing it. 32, 16, 8, 4, 2, 1. No half lives. 1 half life. 2 half lives. 3 half lives. 4 half lives. 5 half lives. So 5 by 138 days is the half life, so it's 690 days. I've done this on the calculator. Listen, there's it is. Right, now let's do question 14, and then I'm going to talk about questions 15 and 16. It says, how long will it take for 20 grams of cobalt to decay to 5 grams? Right, so let's draw the table. This time we don't have activity in it, we have mass measured in grams. Do you see the way I've done the table? There's my half-life, T subscript a half, and there's the time. Let's draw the table. I'm using the ruler. Just keeps things straight and tidy. I'm starting off with 20 grams. Then 1 half-life of 10 grams and 2 half-lives, I have 5 grams. No half-life, 1 half-life, 2 half-lives. So 2 half-lives. What is the half-life in this question? 5.26 years. Just to make sure my table's right. So it's 10.52 years. And notice I've done 2 places of decimal. Do you see that? Because the question's in 2 places of decimal. Fair enough. Now, I'm going to write on the bottom of this so that there's no excuse. Do questions 15 and 16. Now I'm going to talk about question 15. It says, when a radioactive material with a half-life of 24 hours arrives in a hospital, its activity is 1000 becquerels. Calculate its activity 24 hours before, so you're going back in time there. Do you see the way you look at the table? Half-life of -1, so in that box it'll be 2000. Fair enough? Time minus 24, so you can go back in time. Like travelling the points past, I suppose. You'll definitely go back in time. So I want you to draw out that table and fill it in. Fair enough? And the last one, well, I hope you have graph paper. Plot a graph of activity y-axis against time on the x-axis using the data in question 15. Right? Start the graph from t equals 0, activity 1000 becquerels. Use the graph to find the activity 36 hours after the material. So you're going to get a curve. Fair enough? You're going to have your time along the x-axis, you're going to have your activity in becquerels along the y-axis, you're going to draw the curve, and then, as I keep constantly telling you, you read off a graph using the ruler. Listen, there's the ruler. You read off the graph using a ruler, and you have a line on the graph. So I'll be looking for that. I'll be looking for a line on the graph to show me that you have done this. Now, so there's a piece of work that I want handed up. Time-bound questions 12, 13, 14, 15 and 16. Test yourself, page 416. Time-bound, marked and recorded. Your turn to do it. I've done it. Thank you. Toodle pip.